Thanks for showing up. And I'm glad, hopefully everyone's caffeinated. So you're in the WebSocket Applications and Vision for the Future session. And we certainly all know about WebSocket up until this point. We better know about WebSocket. We represent the top 1% of all application programmers, of course, so it's our job to know about it. And we know that for the first time in over 20 years, there is now an official second protocol for the web, an RFC 6455. So we all know we're staring at a new phase of the web with all this good HTML5 stuff. And it's a lot of stuff, right? And we're looking at WebSocket as enabling a lot of this cool stuff to happen over the web in a very efficient way. So, I mean, having a fat pipe, bidirectional fat pipe over the web is potentially could be the butterfly that flaps its wings type of story. So we have 4 experts in WebSockets and real-time communications on our panel. We have Matt, Ilya, Phil, and Peter to discuss some of the interesting spots for WebSocket now and in the future. So I'll let them introduce each other, and Matt, we'll start with you, and your name and what you do, and where WebSocket plays a role.
My name is Matt DeBurgalis. I'm one of the authors of a framework called Meteor. Meteor is a platform for writing applications where most of your software runs inside the browser and communicates with services in the data center. And so for us, the whole story is about the transport between those two. And it's a transport that needs to be somewhat different from what we grew up with in the web. As you said, bidirectional. I think you're going to see mostly data rather than presentation over that transport. I think you're going to see a lot more thinking about sessions and session preservation and state on that connection. So we use today either WebSockets themselves, or we use one of the emulation layers with long polling or whatnot that accomplishes the same thing. But I think in the long run, it's very exciting to have the ability to open a real, bidirectional socket from your client-side application and then talk to different endpoints around the web.
All right. So Ilya Grigorik, I work at Google with the Make Go Fast team and Google Chrome teams. And in both of those, for both of those teams, the primary focus is on web performance in general. So of course, making Google web services faster, but we also know that making the web faster as a whole also plays into making Google faster as well. So we were very much aligned there. And specifically for WebSockets, one of the things that we find is if you guys attended the HP2.0 talk yesterday, latency is a big concern, and we know that we want to build better and more ambitious apps in the browser or across these platforms, and WebSockets is one way to get there. So having that bidirectional way to communicate and also combining WebSockets with other HTML5 technologies is really where it gets really interesting. It's not just about the pipes.
Yeah, my name's Phil Legater. I'm a developer evangelist at Pusher. Pusher is a hosted service, and WebSockets are at our core. The focus is to make it easy for you, developers, to add real-time interactive functionality and user experiences to web and mobile apps. So as I said, WebSockets are at our core. We make it possible for you to add WebSocket bidirectional functionality to your web and mobile apps, where potentially you might either not be able to do it yourself because you're on a platform that doesn't support WebSockets yet, or if you're at the point where you need to scale this real-time infrastructure. And we obviously, as a hosted service, deal with that. And I think our focus, as I've said in the intro, is really about using these technology to create this interactive user experiences and changing the way the web, and Kazing call it the living web, and I just like to call it, the interactive web. So that's the way I think our web applications are going to go, and WebSockets are at the core of that.
Hello, my name is Peter Moskowitz. I'm the developer evangelist for Kazing. Kazing is based here in Mountain View. We are a web communications platform company. We have a high-performance enterprise-grade WebSocket server, and our founders played a key role in drafting and working on the WebSocket standard. My passion at Kazing is to visualize WebSockets, to build applications and demonstrations that help everybody imagine and feel and experience what WebSockets can do for us.
Great. Thanks, gentlemen. So what I'll do is I'll pose some questions to specific people, and if any of the other people want to chime in for comments. And hopefully we'll have some time at the end. There's a mic there, so hopefully we'll save some time for Q&A. So let me bring up, we have two vendors on the panel that are selling WebSocket technology. And when you look at the technology, it's like it's an obvious no-brainer. We're going to use it, right? But are there any barriers to adoption for WebSocket? What do you see from customers? Like, I don't want to use that because of a reason? Are there any of those reasons?
Right.
Go ahead, Peter.
So when it comes to getting started with WebSockets, I think the biggest and the most interesting thing that I see is that we've been living in this world of request response, where the browser has to initiate the request and there has to be a response to that from the middle tier or from the application server tier. And just having this mindset or getting around this mindset and realizing that at this point you have the same functionality in the browser that we used to have in a thick client application before the web was introduced. And back in the client server world, we had a full duplex connectivity all the way to the back end. And when we introduced the web, one of the major inventions was the web browser. And what the web browser introduced was a very dumb kind of functionality, the ability to render HTML, to render markup. And this is what we used it for a very, very long time. And with the evolution of JavaScript, we suddenly became able to run full-blown applications inside the browser. Now we don't have to create markup on the middle tier, on the application server tier, and then send that and have the browser render it in a dumb way. Now we can actually have fully blown applications run in the browser. And once these applications are running in the browser, then there's one more thing that we would really need to complete the picture, and that's to have a full duplex connectivity all the way to the back end, and that's what WebSockets bring to the table. So one thing is getting our heads around this full duplex, truly event-driven experience and event-driven API that we have in WebSockets. The other one is moving away from the way of thinking around request response and realizing that now you can send messages from the browser to the server and from the server to the browser very, very seamlessly. And lastly, how we architect applications. We can move away from, or actually open up and build applications that are not running on the application server on the middle tier. Instead, they are running in the browser. And that way you can scale a lot better as well because you don't have to run them on the middleware and on the application server nodes.
So essentially inertia, overcoming inertia for the existing status quo.
Absolutely.
Right? Okay. Phil, do you have any?
Well, I think there's the obvious things such as browser support. I know it's spoke about all the time, but we are always fighting against browser support, and we rely on polyfills and fallbacks. So that those things are still very important, and you need to prove to clients that you have those things in place. We use fallback to Flash, and then we actually use SOC.js for HTTP fallback. So these sort of things are important, and it's just a matter of demonstrating to potential clients and to developers that this stuff's reliable. And there's obviously the internet infrastructure as well that we've got. I don't know whether we're going to cover that already, but there are things that interfere with WebSocket connections. A secure connection tends to resolve things, but you do need these fallbacks where proxies are going to stop a WebSocket connection, and they happily deal with HTTP.
So that was actually going to be my question to you guys, right? So we have WebSockets as a standard, which is nice if it just worked. But the problem is we do have proxies, we do have a lot of things. So the question, I guess, my question to you guys is how feasible is it today just to use the naked WebSocket API and just have that work reliably, as opposed to, like, if I'm really trying to push something into production, do I need polyfills? What is the checklist? Or should I really just come and talk to you because it's so complicated that nobody can figure it out?
I guess you can look at it in a number of different ways. Number one, there's pretty much all the IE versions that are out there, IE6, IE7, IE8, and IE9, do not have native support for WebSockets. If you look at the mobile space, most of the mobile browsers out there don't have native support for WebSockets. So you definitely do need polyfill, and you need fallback options for that. I guess that's for.
Yeah. Well, I think it depends on who you're building the application for. So if you know the users, I mean, it depends. I mean, generally, if we're publishing something on the web, it's potentially for everybody. But if you know the users, then you might know the platform that they're using. So if you know that they're all using Chrome, you know they're a certain type of user that will always upgrade their web browser, then it will work. We've got a company that uses that target financial clients. So they tend to be in a lockdown network. They tend to be using IE. But we actually found that only 3% of connections failed. So that's actually not a bad stat. But still, you want to reach 100%, so you need this fallback.
Right. So for Meteor, how do you guys tackle this problem?
We don't use WebSockets.
That's one way to do it.
Can we just admit it? They don't work. Like, we use Sock.js as well, and I think the technique of emulate. Look, you want a socket from the browser, right? I don't think anybody disputes that that's the future. You're going to be able to open some kind of connection outbound that's full duplex and bidirectional. That's fine. But yeah, I mean, proxies are a big problem. Another one is compression. So, we find that the downsides of not having native compression when you use a WebSocket are pretty bad, especially when your payload is JSON because it compresses so well. So you're giving up a lot, and we find in production that the different emulation techniques, even just basic XHR long pulling, actually work pretty well for most cases. So what we've done is, in a Meteor app, clients don't even try to use WebSockets. The server will answer on a WebSocket, so you're welcome to, if you have a particular deployment situation that calls for that, that's fine. But we just find in the field that the fallbacks work better.
So actually I had a question for you, Matt. So we've been talking about sort of the user point of view, how it improves the user experience, but how does it improve the developer experience, right? I mean, when I found your site, I said, oh, wow, this is a really cool next generation web development environment, but I mean, could you explain to the audience what you guys do?
Oh, with respect to WebSockets or?
Well, in respect to real-time communication, real-time web development.
Yeah, I mean,
it certainly is different from the traditional web
It's
development.
actually what I think everybody up here talked about. It's applications are crawling down the wire to run on a client, and the reason is that you can generally build a better interface. You can build a more responsive interface and a better user experience when the software is next to the person, and that's always been true, right? Windows desktop software was better in that respect than the web. It's just that it was so much more convenient to go to a URL that we displaced a lot of that old software. But look at like any modern web application, even just a website, uses this technique. The photo browser on Facebook, open the web inspector on these things. The photo browser on Facebook, sending JSON and binary data for the photos. But Twitter, for all the hullabaloo about the slow page load, once that page is up on the screen, they're sending JSON back and forth. Google+, Gmail, right? All structured data, all going over the wire. So these are, I think, the front line of this general evolution away from sending down a pre-rendered page of text and toward an application that's receiving updates from the server asynchronously. And that's what you need, a WebSocket or some kind of connection that has that character to be able to write apps that way.
Thanks. I went to your session, Ilya, yesterday about Speedy and HTTP 2.0. Should I just wait for that and not do anything with WebSocket?
Right. So HTTP 2.0 and Speedy. So first of all, I should preface this and say that as of today, WebSockets do not run over Speedy. They will. We are working on it. There's a spec in progress. And in fact, right now the team is working on the version 4 spec of Speedy, which will have language about how WebSockets should be transferred. So the challenge there is just to figure out how exactly do you map WebSocket frames or the WebSockets protocol to Speedy frames. And we've gone through a couple of iterations, and I think we have a pretty good solution. So then the next question is, what does that even mean? Like, what does HP 2.0 give you? What does WebSockets give you? And if you have this multiplexing and bidirectional stuff, aren't they the same thing? So the short answer is they're not the same thing. HP 2.0 will allow you to send multiple requests and responses and multiplex them over the same connection. So it will actually enable multiple WebSocket connections to be delivered over the same connection, or multiple WebSocket streams, I should say. So you could mux multiple connections, which is nice. But HP 2.0 does not provide any sort of client-side API to say, on message, call back, do something. HP 2.0 will basically just go to the browser and say, here's your resource, and then the browser can put it into cache or do whatever it needs to do with it. So it's at different layers in the stack. So those two things, I think, will play well together. And I think one of the challenges that we have is, for example, the WebSocket group is currently working on WebSockets mux, right, as a proposal. And then HP 2.0 will kind of give you that, hopefully, for free. So then there's a question of, like, are we just doing the same work twice? And of course, a good answer to that as well, we still need it for HP 1.1. But it still feels like we're duplicating the work a little bit.
Good point. And as you pointed out in your talk yesterday, that whenever we solve a problem, we introduce yet another problem. Yep. And we're talking about latency in your talk. So part of the upgrade, well, part of the experience of WebSocket is the upgrade. Mm-hmm. Will the upgrade add latency sometime in the future? Are we going to be talking about the handshake adding latency to the web?
Yep. So just a quick comment. When we solve one problem, we introduce another. Hopefully, we won't introduce another, but hopefully, we will unlock some other problem that was just hidden, right? And I think that's what we're finding with HP 2.0. Once we solve the problem or the bottlenecks in HP 1.1, we just stumble into other bottlenecks in TCP and other things that were previously just hidden from us. So on the handshake side, I don't have a good answer for WebSockets. In fact, this is something that I'd be curious to hear your guys' take on. But I implemented a WebSocket server way back in the day, like one of the early drafts, draft 76. Life was simple, man. You send a request, you get an upgrade, you're like, okay, I'm done. I'm talking WebSockets. Nowadays, it's like extremely complicated. There's extra RTTs, which complicates things, right? So you make the GET request, which is already latency. Then you need to make another request, which is more latency. So you introduce all of these delays, which is kind of antithetical to this whole real-time experience that you're trying to build. In HP 2.0, and specifically in Speedy, we are running over SSL exactly for the reasons that these guys mentioned. There's a lot of proxies that get in the way, so we need the end-to-end encrypted tunnel just to push the frames without anybody interfering with us, which is kind of unfortunate. And SSL specifically has a penalty when you create a new connection. There's the SSL handshake, which introduces more RTTs. So now imagine you have that, plus WebSockets, handshakes, and now you're waiting for 2 seconds to send any WebSocket data. That's a terrible experience. So I think that's something that we need to figure out. I don't think there's been any conversations between the WebSocket group and the Speedy guys to see if we can collapse those things and do it better. But right now, Speedy, or the HP 2.0 working group, is trying to solve the same problem that WebSocket group ran into with this whole handshake business.
Yeah, just to confirm, SSL is the way how most of our customers deploy their WebSocket applications. They are running WSS WebSocket over TLS, exactly for those two reasons that Ilya mentioned. One is to establish the tunnel, and the other one, many of our customers are financial institutions, and security is essential for them.
Yeah. And generally speaking, right, on the desktop, on your regular desktop browser, you will likely get a working WebSocket connection. Try and access it on your mobile phone. Because all the carriers have some sort of proxies in between, you're basically mostly guaranteed that it will fail unless it's SSL. So that's one good reason to look at SSL.
Yeah, I remember when I used to work for an investment bank, proxies were always a problem. They were connecting to a server across the street. There was like 17 proxies I had to traverse. It's like,
yep, that
machines across the street, for God's sakes. Well, speaking of mobile, so we have cloud and mobile as two major arrows for us. Are there any advantages of WebSocket in those environments, specifically for mobile and cloud? Phil?
Well, I can't confirm it, but if you think about a WebSocket connection, it's a single persistent connection between client and server. Other older Comet solutions use two connections, one for push from server to client, and the other one for kind of commands from client to server. So that has to be more resource intensive than a single connection. So in terms of mobile, sorry, I would think that WebSockets are a more efficient way of communicating. So I'd really like to do a test on that, have an application that connects over long polling, have another application that connects over WebSocket, and just have two mobile phones running and see what the battery drain is. I think that's quite an easy test we can do.
So one very kind of simple piece of data that I have for performance is an average request response, just the headers in HTTP is about 800 bytes. So if you're sending your JSON payload, which is like, message hello world, that's your 12 bytes or whatever it works out to be, you're appending 800 bytes of HTTP headers on top of that. You do the math. WebSockets allow you much more efficient framing, so you'll add literally bytes on top of that, which could be significant.
Yeah, and obviously for mobile, the battery is the main resource, so these sort of things really do matter there.
Yeah, so speaking of mobile, two things to add to that. One is battery life. I think not only do we need to better understand how battery life is implicated when you use a WebSocket connection on mobile, but also what measures you can take to save the battery life, basically to see how the user is interacting with the application, monitor that, and maybe scale down the number of messages that are sent to the mobile device or that are sent from the mobile device. The other very mobile-specific thing to think about is whether the connection is there. Very often on a mobile device it goes in standby mode, or you turn it off, or you go in a tunnel and you get disconnected. So features like automatically reconnecting to the source or reinitiating, restarting the connection is another critical one that we don't really see in a desktop or laptop kind of environment.
Sure.
Yeah, I just wanted to add one more thing. That we kind of talk about WebSockets, and we think about browsers, but WebSockets are a protocol, so it's not just web browsers. There are libraries out there to let you create native mobile applications, desktop applications, server-to-server communication. It's really a protocol for real-time communication on the web. So we've got iOS libraries, Android libraries, .NET libraries. So it isn't just a browser.
No, Matt, do you do anything specific? I mean, I know you use Node on a server. Do you have anything on the client side that specifically enhances mobile applications?
Well, I agree. The biggest problem with mobile is the networks start to get really shoddy. And so you have drops, you have disconnects, you have packet loss. What we have found is that and we just took a page from the architectures of the 80s and 90s and the rise of TCP as a transport. The semantics for replay and reconnection are probably best done higher up in the stack. And WebSockets actually look pretty good for that because they don't get in your way. It's fine if you lose the connection, you can reestablish one. I mean, the overhead is unfortunate because of the legacies of how we actually talk on the phone to start a connection. But you want to be able to, so here's an example. The original web architecture where you're delivering a document over HTTP, something that you don't worry a whole lot about is message replay. Right? It's no big deal if you issue a couple of gets. It's no big deal if your initial request is lost and you just reissue it. I mean, you hit reload in the web browser. And that does not carry over very well to this new model where you're sending these messages back and forth, and some of them may be commands that have state-changing effects when they arrive. So you need a story for how do I, over this transport, whether it's a WebSocket or an emulation of a WebSocket or something, how do I make sure that my messages get delivered and that they're executed once? How do I replay things when I lose them? And I suspect that a lot of that is going to take place not in the low level, the transport, but rather layer 6 or 7 or wherever it is these days, right? The actual application level. So Meteor, for example, has some opinions about what the right way to do replay is and where in the protocol stack that lives, but that's probably not the same as what you're going to want if you're doing more of a big fan out of broadcasting events. So I think WebSockets rightfully sit below that layer, and I really just think of them as TCP sockets for web browsers.
So you think history is going to repeat itself as it did with TCP, that other things were built on top of TCPs?
Oh, yeah. Yeah, I mean, WebSockets have some hooks for this, right? There's sub-protocols, and there's the framing is correct, I think, to be able to do some of these things. So yeah, I think you'll see a lot of innovation on top of that structure. Speedy as well, like being able to mux connections and then use those in different ways over the same actual socket is really valuable.
So that's interesting. So what do you other gentlemen feel about that, about having these other things live on top of WebSocket as opposed to directly programming against the WebSocket API?
So as Matt mentioned, there's ways to mux or build other protocols on top of WebSockets, which is great because basically the WebSockets gives you this promise of a very low framing overhead, bidirectional communication. Like that, these are the building blocks, right? And it's going to be reliable. So I think there will be interesting things built on top, and we already see examples like Kazing has great demos of XMPP running on top, AMQP, all kinds of protocols, right? Really cool stuff. But at the same time, I also want to highlight that WebSockets is also not the only technology. So for example, we have a lot of new APIs that are coming to the browser. For example, we have server-sent events. That's not a new API. It's actually existed for a while. It kind of doesn't get mentioned very frequently, but it's very convenient. It's basically, it's a one-directional way. It's a way for the server to push data to the client without any of the kind of additional overhead of doing the WebSocket handshake and all the rest. It only transfers text data, and it specifies a specific framing format. It has auto-reconnect APIs, like everything, all of the stuff is built in. So if all you need is just server push, that could be a very good answer, and it works pretty darn well today in your browser. That's cool. We also have, recently, Microsoft published a new spec or a new proposal for the Streams API, which will allow XHRs to stream binary data. This was a big hole previously where you couldn't, right? We always said, oh, to stream binary data, that's what you need WebSockets for. Well, if this is implemented, this is just a proposal at this point, then with XHRs, you'll be able to stream, I don't know, video or other content directly. We also have some proposals for just like raw sockets. I think we're still discussing as to whether that's a good idea, but there's certainly a lot of people that believe that is something that should be there. So thumbs up from here, yeah. So there's a lot of different technologies here, right, that we can leverage to build on these things.
So are they complementary or are they orthogonal?
I think they're all complementary. So if you need to really kind of sit down and build a matrix, right, of like, what am I trying to get for my app and what are these technologies give me? Because, for example, server-sent events, just one-way push. If that's all you need, that's cool, if the client doesn't need to talk back, right? If you need bidirectional and you want to layer some more intelligent protocol, WebSockets is probably a good call. If all you need is to do streaming of binary data, assuming this Streams API comes in, that's probably a good deal. Like then you don't have to do the WebSocket. So all of these things I think have a very good spot for different applications.
But currently, like for example, Phil, like how many of your customers are looking at push applications versus sort of like the next generation?
Yeah, I mean, I think a lot of people talk about WebSockets and they say, I want to add a push notification to my app. And that's fine, and like the idea of live content, delivering live content to applications is great, and it's a progression, and it's something we can do a lot easier now than we have done in the past. But I do think that the excitement of WebSockets is the potential to add interactive functionality to applications. It's not just about push. I think the event source, server-sent events, is fine and can be used for delivering this live content. But I think generally when we do abstract upon these raw technologies because we want a little bit more than they offer. For instance, the event source does auto-reconnect, WebSockets doesn't. So you would need a layer on top of WebSockets to handle reconnection. But I think there's generally a little bit of chat that goes on in terms of subscribing. So the number one use case for this sort of technology is PubSub. You want to subscribe to something, and you want the ability to route and publish information on a certain topic or subject or channel. So I think that's very important. And so going back to your first question, I think it's about WebSockets is about building these interactive applications. We're seeing some really good examples in terms of collaborative apps like Google Docs is a great example of a collaborative application. But I think we need to see people using WebSockets to build more innovative examples like that.
Right. So, so we have all this cool functionality with WebSocket and other types of real-time communication. So one of the tenets of HTML5 is removing plugins, right? And one of the big reasons is that we have 4 ways of getting, for the black hats to get in, right? So we want to reduce that to only have one door in. But now we have this real-time pipe. Are there any security issues now that we should consider in regards to a real-time pipe, like WebSocket or any other real-time communication channel?
Actually, before that, may I just jump back to the previous one real quick, and then we can move on to
Sure.
security. I'd like to approach this higher level, richer business protocols question and the ability to build these protocols on top of WebSockets from a slightly different angle. Many of our customers are large enterprises, and they do have very sophisticated enterprise apps deployed within their firewalls. They have messaging deployed within their firewalls. And one of the things that brings a major change to their lives is that now they have a way to extend the reach of these rich business protocols all the way to the browser, all the way to the end user, using these higher level protocols on top of WebSocket. So one of the things that we do that is the most popular with our customers is JMS. JMS is this Java messaging service that many enterprises use. And simply by having JMS-like APIs for all sorts of clients, including JavaScript, as well as Flash and Flex and Java, now the customers can take their JMS infrastructure and extend it all the way to the browser, and their browser application code speaks the exact same terminology, the exact same language that they speak within the firewall, within their within the enterprise. And this is very popular, especially when it comes to trading applications, when it comes to betting and gaming kinds of applications.
Okay, so that's a good point. So in regards to security, does a fat pipe offer the black hats other ways of getting in? So anyone?
Anytime you provide any new API, you provide a hole for somebody to sneak into. You still have HTTPS, right? So you can run your connection over SSL, which is great. So you have the protection of that. One thing, I guess, in general that you want to be aware of is if you have built your own custom protocol and now you're layering it or pushing all this data in a custom protocol through that pipe, you're on your own for ensuring that the data that's flowing through that pipe is what should be there, right? So for example, if you're just doing request responses, HTTP provides a lot of mechanisms to do authentication, verification, all of those kinds of things, right? You can use existing appliances to kind of rate control and authenticate, et cetera. Now that you have this pipe, you have to do that yourself. So that's just something you need to be aware of.
Yeah, that's a great point. I was thinking before, you asked about are all these different techniques orthogonal or complementary? And you look back 30 years ago, TCP was one of many things that sat on top of IP. And it's funny how most of the other ones just faded away, right? We really settled on a particular higher level transport that had the right characteristics that turns out 99% of what you want to do on the internet slots in very nicely too. And I mean, that was also back when I don't think IETF really required a security section, and you just had the Wild West. People would make these protocols and they didn't know what they were doing, or they didn't care. And yeah, you had grossly inappropriate things at the protocol layer. I suspect we're going to have to live through that again, right? I think we're in this period where everyone's sort of casting around for the right level of abstraction and the right kind of transport. A lot of that work isn't being done with respect to, I think, the clearest sense of how to do security. And my guess is that we will converge on something that's well done and that becomes an adopted standard, and everybody can essentially build their service on top of that. Because you're right, like most applications shouldn't be inventing new security paradigms while they're trying to get their data into the web browser, right? And that is unfortunately where we are today.
Any other comments, John? So we have this functionality. Hopefully, we'll address, and I guess we are addressing some of the security. What new types of applications are we going to see? I mean, what new types of development environments? What new types of telecom collaborative applications beyond just simple push, you know, the canonical pushing prices to a browser, right? That's what, or a chat application. I mean, okay, we've seen this for 10 years since .com. So what are the next generation collaborative things that we can build with WebSocket?
Well, so from the meteor perspective, the model we like is, if you look at APIs on the web, they're almost always about synchronizing or coordinating two views of the same data. And when you really follow that path all the way down and you have a way to have a distributed app, so you've got all these different clients, thousands or millions of clients running at the same time, and they all have a related view of the world, right? So some set of data that they share, you can build a lot of really interesting things. So, you know, that primitive lets you get away from this sort of, let's build a chat system where we've got messages that just get, you know, inserted into the DOM, and let's actually build an application whose business logic and where all the heavy lifting is actually happening on the client with this local set of data that it has access to. I mean, my guess is that to some degree, it's not that there are going to be new kinds of apps, it's that we're going to throw away the implementations that were done using web technology, like the you know, HTTP, HTML kind of stuff, and rebuild them in this new style where, I mean, web browsers, you've got OpenGL, you've got sound, you've got, right, all of these things are now possible inside the browser. And I just suspect that it'll look a lot like, you know, when we finally could write real software on desktops and PCs, and it'll just, you'll see this real explosion of newer interfaces and more interactive techniques that are just too difficult to do with the web.
Yeah, so let me try maybe a roundabout way of answering this question. I don't think there's a specific, like, one application that is a killer application. It's just the way we distribute these things and what we can enable. So to backtrack, maybe some of you guys saw this. There's a project that kind of circulated a few weeks back called WebSocket, which is, like, blew my mind. It's the most awesome thing ever. So it's a glorious hack. And the way it works is it even works in IE6. So the idea is you have a GIF image, and the browser, when it reads the image, it starts to display the frames, and it starts to display it even before it receives all the data, right? So you can stream data through a GIF into IE6, and that's your socket. So, I mean, that's awesome, right? This is WebSockets of the 90s, except nobody knew. We just found out. So really cool stuff. But the reason I'm saying this, like, everything old is new again. Right? So we're talking about all of these technologies. So the browser, for the longest time, the browser has been, or it placed kind of a straitjacket on what we could do inside of it. And that straitjacket was HTTP request response. I think in a couple of years, you look back and you find that the browser has all of the capabilities that you find in your native environment today. You can open a socket, you can even talk UDP. We have WebRTC working on data channel proposal, yet another API, which will actually give you ability to do unreliable delivery. Right? This is part of WebRTC, but it's applicable to anything, so you can build games, etc. So all of these things that you previously had to have a native app, you'll be able to do in the browser. And then the question is, well, now that you can have all this flexibility to build any app as you would on a native platform, what does the browser give you on top of that? And the advantage is there is, well, you don't need to build it, ship it, shrink wrap it, or put it on App Store. It's right there, it's available. You can push out notifications instantly. There's collaboration. So it enables a new class of applications around that, which I think is really interesting. And I think that's where we're going to go.
Yes, I mean, I think of the web now as our #1 communication platform, and I see WebSockets, and specifically, wrapping it in with HTML5 WebSockets as being core to this new communication platform that we've got. So I think it's about using the new technologies we've got with HTML5, as well as the ability to instantly interact, to build, either these collaborative applications, or I think we've been, specifically us guys that have been using this technology for a long time, and the amount of times we've seen flashing grids or trade tickets, that it's sometimes quite difficult to see beyond that. And I think we need to be bringing in people who are UX people that understand ways that people can interact with these applications, these web applications in different ways, thinking beyond just the mouse, thinking cross-device communication, the way that we can use the accelerometer and things in our mobile devices. So I don't think there's a specific answer about these killer applications yet, as was said, but I think we now have WebSockets as a great way for real-time communication, and the other technologies within HTML5 and and mobile native as well, that open up the opportunity to really experiment and find better ways of communicating.
Pretty much everything was said before me. So I'd like to just very quickly summarize that we see two fundamentally different classes of applications that our customers are building. One is the type of application where the data, a large amount of data, is available on the server side that needs to be pushed out to a large number of clients, to all sorts of heterogeneous kinds of clients, including mobile. So this is more of the trading and betting kind of application. And the other type of application is more of the peer-to-peer kind of app where
trading and betting, are they different?
Trading. And so the peer-to-peer kinds of applications where you have a device or a browser or a desktop app that's interacting with another device or browser or desktop app out there. So I think that's going to be a very exciting and interesting one.
Yeah, just to point on that, it can be one-to-many as well, which is the exciting thing. So it can be many people collaborating and communicating.
And there's one thing that I think we should very quickly mention, the relationship of HTTP and WebSocket, and what is happening with HTTP now that WebSocket is there, and whether HTTP is replaced by WebSocket. So basically, and probably needless to say to many of you, is that HTTP has its own place. HTTP is absolutely here to stay for serving up assets, things like HTML and CSS and JavaScript and images. And then WebSocket is going to play a very crucial role in the bidirectional real-time data exchange. So as we said, having a full-blown application running inside the browser, basically the starter app gets to the browser, tends to get to the browser through HTTP, and once the app has been downloaded, we don't have the maintenance nightmare like we had in the client-server world. It's all running inside the browser, and at that point the browser can talk to the backend, and the application can get the dynamic data from the backend through WebSockets very easily.
So maybe just a quick comment on top of that. I've actually seen a couple of companies or open source projects where specific projects are actually replacing or trying to replace HTTP with WebSockets. It's like, to hell with it, right? We'll just open a WebSocket connection and we'll mux our own protocol to deliver all the resources. Not a good idea. They have good intentions in the sense that there are limitations. So for example, if you're transferring these small payloads and you have this giant overhead on every request, yeah, it hurts, right? So that's one good reason why I think people are doing this. But in the long run, that's exactly what we're trying to solve with the HP2.0. And by muxing your own protocol on top, you bypass the browser cache, all of the kind of prefetching capabilities of the browser, all of these things that you get for free, right? So I'm hoping that we can, well, not hoping, we will address that in HTTP 2.0, and WebSockets is not a replacement for HTTP.
Right, good point, good point. Okay, I think we are out of time. So I guess we'll be up front for a few minutes until I kick us out. So thank you, everybody. See you next year.